welcome again and thank you for joining me today. Still working from home, this is from my home office, and I really wanted to share some thoughts with you. So recently I've been talking to a lot of companies, particularly in the medical device and instruments side in life sciences. And one of the things we're looking at is how to change the way they operate within a laboratory or a hospital or a medical facility of some sort when doing biotesting, etc., or connecting or using or making available features to medical devices. So it's not that things are not working well today, it's just maybe there's other things you could do with some of the technologies available with low impact to make things a lot better. So what am I talking about? So if you take a medical facility, maybe a hospital or maybe a laboratory or your own surgery, then in that surgery or hospital, laboratory or that medical facility, you may have, and you probably do have, a number of appliances or devices which you actually use for patient care. So in the top here you can see you may have a surgical device which may be in the theatre. You may have a biodiagnostics device which you use to do sampling with, whether it's blood or other biosamples. And you may have an analytics device which is used in some way or form in doing diagnostics with, well, continuous diagnostics with patients. But what you'll find with most of these devices is that each one of these devices will have its own compute unit, as you can see from what I've shown here in the diagram. And with these compute units, it's one computer attached to one device, and typically a printer or other peripherals which may be attached to it. No great shakes there, you see this all the time. But what challenges or what are the key limitations of some of these things is that each device does need its own dedicated computer, which means that if you've got multiple devices in a room, you need space for multiple computers. Typically, on each of these devices, 1, 2, 3, and there's many in your facilities, software running on the computer is dedicated to that one device. So you can't use that computer for a secondary device or instrument or appliance. It ends up taking a lot of physical space, and you need more space with the computer. And then when you want to do software changes, when there's an update to the software for, say, the surgical device, and they just need to do a bug fix on the software or there's a feature enhancement, then one of the challenges you have to physically come to the computer and actually do an install on site and reinstall the whole software just to get the updates. And typically that means the user can't do it, it means an engineer's doing it. One of the things that could be a challenge is that maybe one of your instruments or devices could do multiple functions. So you may have a bio-testing device which could test for 4 or 5 different types of biotests. However, because on each computer the software is dedicated to one test, then it's possible that you can't use multiple tests coming out of that single apparatus. What do I mean? Well, at the moment, you've got one software installed on one computer to one apparatus. Say you come out with a second test, which could use the same apparatus, well, you may be facing the challenge of putting a second compute node next to that apparatus so you can do 2 software tests. Well, that becomes complicated because it's more footprint and it becomes costly. So adding additional functionality to the apparatus by adding additional testing software could be a limitation. But it's the way we work today. And the other thing that could be limitation is the actual apparatus in the computer is static and it stays in one location. So if you leave the laboratory room and go to another room in the medical facility, or you go to another building, can you get access to the apparatus and the data stored on that apparatus? Maybe, maybe not. You probably have to come back to the room to get the data from the apparatus. Or if you ended up in a operating theatre and you had to do a recalculation and you needed that apparatus, you'd have to leave the operating theatre, come back to the room, do the calculation, then go back. So That's what I mean by the apparatus and the computer being quite static. You're limited to the location it's actually installed in to use it. So we have this technology called VirtualBox, and VirtualBox allows you to change some of the dynamics of what you already have without it costing you a lot of money and without it being intrusive and a redevelopment of your applications. So how does it help you? Let me just talk about that for a moment. So let's take these three devices, and what would we do differently to them to digitize more the appliances and the apparatus in your actual laboratories or medical facilities? Well, one of the things you could consider is if you could take all those compute nodes, 1, 2, 3, and centralize it over to a central location. You may call it a data center, it may be a central room in the medical facilities, it could be in your own premises where you're developing software. If you could bring it to a central location, then you've already reduced the footprint within the medical facilities. Well, if you could then remove some more printers to reduce the footprint and more, what do you do then? You can clearly see you haven't got your software next to your appliance. What you could do with doing is having something called a dumb terminal. It could be something that's not intelligent to your apparatus. It could be your personal laptops or the user's personal laptops. It could be just an old machine lying around. Using that to connect to the apparatus and to the one single printer. So now you see you've connected three devices to the single computer. In this case, a dumb terminal. When I say dumb, it just means that there's no local software that the apparatus can see to make it intelligent to the apparatus. So in the case of a surgical device, the surgical device software is not on the dumb terminal. In the case of the biodiagnostics software is not on the dumb terminal, and the analytics software is not on the dumb terminal. But they are connected to the dumb terminal, and there is a printer there. So how do we now get the software to those apparatus? Well, we have the product called VBox, and what VBox does, it connects to those three machines that we now centralize. It takes the software and it publishes it through a secure connection to the dumb device. And what the VBox does, or VirtualBox does, it actually makes the software present on the dumb device, and when the apparatus, whether it be the surgical device, the diagnostics device, or the analytics device, connects to the dumb terminal, the apparatus thinks it's speaking to the software local inside the medical facility, when in fact the software is actually running in the central facility, whether it be in another room in the medical facility, or whether it's in another building or in a data center somewhere else. So what's the advantages of doing this? It now means that you have a single computer, smaller footprint, but it now means that you can have the software published through a menu approach. So in this instance, you've got a menu of three softwares available on the dumb device for three separate apparatus. So whenever you want to run the biodiagnostics, you launch and click and launch the biodiagnostic software. Whenever you want to run the actual surgical device, you launch the surgical device software. When you want to run the analytics instrument, you launch the analytics instrument software. You have a choice. But what makes it even more interesting, you can add another computer in the central location and add another menu item, and in your biodiagnostics you could add another software layer without going to the actual medical facility and make that software available for a second test. By having everything in the central location, what it means, you can do software updates, you can add features, all from a central location, and through this menu-driven approach, you can make it instantly available to all the apparatus, devices, or instruments within the medical facility, making the proliferation of medical diagnostics and testing much easier and faster using internet and security to actually deliver that connection to your medical diagnostics facilities. This is one way that VBox is being used to try and drive more efficiencies in the healthcare industry, particularly around life sciences, by digitizing what are legacy or old archaic architectures for testing instruments and appliances in the medical industry. So, what are the key takeaways from this? Well, the key thing is that it enables multiple devices to be used on one computer, and it has special features to do that. it means that your footprint is smaller in your medical facility and you can get more instruments in there versus more computers into the same space. Centralizing all the management of all the software for the multiple devices, allowing for extension of features and instantly deploying them, allowing for updates to software and instantly deploying them, allowing choice of software to be used on whichever device. It lowers your cost of goods, making the instrumentation and testing available to a wider geography. We have security features built in which allow you to access the device and protect patient records, protect patient information, which may be subject to HIPAA compliance. So it allows you to continue to contribute to HIPAA compliance and your regulations around that, and actually have remote access. It's encrypted, again, very, very important, and you can have access to the software from any device anywhere. So if you have an instrument in a room in your medical facility and you go to the surgery through an iPad or through a dumb laptop, you can actually access your instrumentation software from within the surgery rather than coming out of the surgery and going back to your office. It's got this unique USB serial port feature which allows you to connect any multitude of serial port devices or USB devices to a dumb terminal, meaning a terminal without the local software installed, allowing your apparatus to think it's connected natively to the local machine. So there's a whole bunch of features that give you this architecture and allow you to do this with your medical devices and instruments. I encourage you to take a look at VBox for your solutions. There are many, many more solutions coming. I will be releasing some more videos around the medical and healthcare industry as to how else you could use VBox. But this is one reason that you should think about using VBox. It is, in the GDI report, the top solution for this type of use case. I encourage you, please take a look at it, download it. It is free to download and take a look at. And hopefully this information has been useful. Keep safe, and look forward to speaking to you all soon. Thank you very much. This is Mickey signing out. Bye.